I've been able to add some more numbers to our chart of 5090 and 50 series in general benchmarks leading up until we get the official review embargo date. For 5090 versus 4090, we already had some official results from Nvidia, and then followed by a couple more official results from Nvidia. I just am using the non-multi-frame gen results to get more apples-to-apples comparisons. Those were showing a little over a 30% performance update. Now I've added in some leaked results, but let's clarify with leaks. These are not just somebody posting a random number on Twitter and it's saying, "Trust me, bro." These are when a reviewer gets a 5090 and runs synthetic benchmarks that have an online database and aren't disconnected from the internet and aren't careful, then their 5090 results get uploaded to that online database. So for example, beware of a white screen flashbang warning, team, okay? All right, anyway, this is Blender. And if you look at Blender, you can search their database, and we have a 5090 result available for Blender. It shows a median score of 17,822.17, a median of 1, meaning there's only one 5090 result here, which does mean that while this is an officially uploaded result, that doesn't mean it couldn't be like somehow be an outlier, and if you had 1,000 more results, maybe average out a bit differently. So that's something to keep in mind. For example, with the 4090 running the same test, they have over 1,000 results, and the median score is 13,064.09. We also can't guarantee that the platform the 5090 was running on is the same platform that would match, the average of our 4090 results. So that is something to keep in mind when going with this. However, that does show us a 36% performance uplift in Blender for our one 5090 result, which again, on a different platform than those 4090 results, and it's the average of those 4090 results. But still, this number stays within the realm of what Nvidia seemed to be indicating. Now, Blender is not a gaming benchmark, though. And you know what? Neither is Geekbench. It's a synthetic benchmark. However, they do have a Vulkan average, a Vulkan score in Geekbench. They also have OpenCL. Now, I'm getting a 1.12, in other words, a 12% uplift for OpenCL, and I'm getting a 1.33 uplift, so 33% uplift in Geekbench Vulkan, but where are those numbers coming from? I spotted over at videocards.com, and all my sources will be linked in the video description, a title, 5090 appears in first Geekbench, OpenCL, and Vulkan leaks. It seems like they're getting their information from the BenchLeaks Twitter account, which I'm pretty sure is a bot that scans these types of databases and publishes interesting information about them when it's spotted. Anyway, there's several 5090 results. Videocards.com laid their results out here where each one is taken separately. What I did when converting it into my table is I averaged the three 5090 results and then divided that by the 4090 result to get the performance uplift. They're also expressing their percentages in a different direction than I am, where they're setting the 5090 score as 100% and then showing everything as a percentage of that, whereas I'm doing it as a percentage uplift versus the 4090. So the 4090 is considered the baseline because I'm looking at generational uplift. Anyway, that's why the numbers might not exactly match up here when you look at my table. Comparing in a different way. So here we got the three 5090 results, where one is noticeably less than the others, so that's something to keep in mind. Again, I averaged them and divided by the 4090 average in the Geekbench results. And again, the OpenCL scores seem to show less of a separation between 4090 and 5090. And again, I averaged the three results and divided, and that's where we're getting these results in the table. So that's showing a 12% uplift for OpenCL on average and a 33% uplift on Vulkan. So other than the OpenCL result, everything here seems to be pointing to a little bit over a 30% generational uplift. The geomean of all of these results, even though some are gaming benchmarks and some are not, like Blender, pushes about a 30% uplift. Notice the average is being brought down by this 12% outlier. And remember that the shader increase, if you just compare, just raw shader count, 5090 versus 4090, is about a 33% increase. So that's kind of where we're at here. All of this seems pretty in line with the shader count increase. Anyway, so that's what we've got for the new 50 series leaks. But what about AMD? So there's still a big question on what exactly is going on with the 9070 XT and the 9070. How powerful are they, and when exactly will they launch? All AMD said in their official announcement to press was Q1 2025, and that's 12 divided by 4 is 3. There we go. 3 months, right? So January, February, March. There's a wide range of time that could indicate. Now we're getting this post saying that ASUS Turkey is teasing them as coming soon, but again, coming soon could be interpreted as literally anything. Does ASUS Turkey even know when they're coming, or are they just trying to hype up their product? That's a good question. I was looking to see if AMD had any further comment. We did get this quote from AMD directly. Now, to be clear, this is on a Meet the Experts interview and is getting a direct quote from Donnie Wolagroski, AMD's Senior Processor Technical Marketing Manager, saying, "All I can say about Radeon 9000 is that what we have said is what we can say. We think it deserves its own time in the spotlight, and at CES, things can get kind of washed under a massive amount of information. So stay tuned. It won't be a long time before you'd be hearing more about it in the future." So again, no specific date, but what they seem to be implying is that the Radeon 9000 series will get its own launch event, and again, we have the Q1 2025 for when they'll be available, but other than that, we don't really know. There's been a number of posts and listings for them that seem to indicate a January 23rd availability date, or at least a pre-order date. But again, those could be placeholder numbers being posted on websites that don't actually know themselves. So I wouldn't read too much into those. But that's the closest thing to a date leak that we have. So we'll have to see. I'm going to warn you about another light-ish, it's not pure white background, but a light-ish background. We're going to the Chip Hell forums for a second. And this is machine translated by my browser into English. This is Chinese language. And some of you may remember our Jensen on the Lakers jersey here. Zhang Hao. I'm butchering this pronunciation. I do apologize. Not sure how accurate to take his leaks, but he's talking about the next generation, not RDNA 4, but UDNA. That's at least kind of interesting. So what does he have to say about it? He's saying the desktop, well, also he's talking about desktop CPUs. So anyway, just general kind of AMD update, saying that the desktop Zen 6 CCD is an N3E process, and the IOD process is N4C. The GPU, UDNA, is also N3E process, and the big core flagship is back. And my aunt has also said this, because my uncle works at Nintendo. Sorry, when I was a kid, that was like the, whatever. Anyway, the point is, the interesting thing here is if that's true, that means that, again, AMD has said that with RDNA 4, they're not chasing the super high-end. They're going for the main market share, whether that's because they just couldn't compete with something like a 5090 or whether they really were just going for more of the mainstream market. We don't know, but that's what they've said that they're doing with RDNA 4. We also know that they're going to shift to UDNA to try to bring their, get rid of their split between their professional series and data center stuff and their gaming cards. UDNA will be the bringing together of that, right? Getting back onto the same kind of design. And they're saying that with that, the big core flagship will be back. So maybe AMD is not permanently out of the high end. They're wanting to get back there, and maybe it's UDNA where that happens, and also with the jump to the N3E process. Also interesting, if it ends up being true, is on the APU side. So we're talking like integrated graphics and CPUs for like laptops, mini PCs, maybe even handheld PCs, that kind of thing, depending on what power level you're talking about. The next generation of Halo, so probably referring to like what do we have? Strix Halo with like that goes all the way up to 40 compute unit that just got announced. Which I'd really like to test out against some like weaker discrete graphics cards. I'm just interested how powerful that flagship, APU is going to be versus discrete desktop stuff. But anyway, they're saying that it will stack 3D, so like 3D V-cache, to improve performance of both the CPU and the GPU. That would certainly be interesting if true. And they're saying that the packaging method will be known in the second half of the year. At present, the simplest one is sharing. Sony will also stack 3D on the console side, but Microsoft is not sure yet. So that's interesting, because there has been a lot of speculation over whether consoles would make sense to go with 3D V-cache due to the cost and die space and whatnot. is actually cost effective for what they need to do there. If this leak is true, they're saying that Sony will, and Microsoft is still deciding. Of course, could all of this be utter nonsense? Yes, that's how leaks and rumors go. That being said, we are seeing a listing, at least in China, for a Ryzen 5 7400F CPU. Now, the F indicates that there's no integrated graphics, and you might be like, wasn't there already a 7500F in Chinese markets? And the answer is yes, but this could cost even less, apparently, showing up for $116. Now, this would be interesting if this performs anywhere near something like a 7600, because the problem with this kind of newer 7000 series CPUs, I know we're already on to the 9000 series, is just that it hasn't got a really great low-end PC build, or not even necessarily low-end, but like super value-oriented PC build. A lot of the really, if you're restricted on budget PC builds, would still have to jump back to like a Ryzen 5000 series or something like that. So if we could get something in that like $100 range that was widely available, but still had close to 7600 Ryzen performance, which again isn't that far off from a 9600X, I think that would be super interesting for more value-oriented PC builds and kind of a lower budget range, which would be pretty cool. Again, this has only been spotted in the Chinese market so far, but it would be nice if we start to see that more worldwide. Now, this would also be especially interesting in regards to what about GPUs like the Intel Arc Battlemage GPUs, which are exciting from a value proposition, but there's been that big question mark over the CPU overhead compared to AMD and Nvidia counterparts. Well, if you're doing a newer build and could get a more budget-oriented CPU that's still fairly powerful and could likely avoid any of those bottlenecking issues by being powerful enough to push past it, then I think this could be an exciting combo for that type of a value build. So that would be interesting. Speaking of which, if you didn't watch the reviews, I've done a couple of review videos for the B570. Now, when I choose GPUs to compare against, it looks like a lot of outlets chose different GPUs to compare against than I did, and that's great because then you get a lot of additional information depending on which reviewer you look at, which is awesome. That's why it's always a good idea to watch multiple reviews and multiple review outlets because we test and focus on different things, especially if you're actually planning on buying one of these. I focused in on comparing against the nearest price competitors from AMD and Nvidia. So from Nvidia, the nearest price competitor to a $220 product is the RTX 3050, and I had the B570 absolutely destroying it. And then from AMD, the nearest price competitor is the RX 6600, and again, the B570 was significantly faster, also had a better upscaler, and compared to both of the AMD and Nvidia options, which are 8GB cards, the B570 had 10 gigabytes of VRAM. Now, one thing I didn't have time to do, because quite frankly I need to move on to focusing on my 5090 review, is I didn't have a chance to test out lower-end CPUs. So I had a cautionary segment at the end of the video telling people to watch other review outlets who did have a chance to test out lower-end CPUs. And we did get some of that from Hardware Unboxed and Gamers Nexus. So in Hardware Unboxed, for example, they tested on a 9800X3D, so to remove any CPU bottleneck by using the most powerful CPU, which is traditionally what you do in a GPU review to isolate the GPU variable. But he also compared with a Ryzen 5 5600. Now, you can see those results at native resolution as well as upscaled, and upscaling reduces the burden on the GPU and is more likely to reveal CPU bottlenecks. Now, they were reviewing up against a 4060 and a 7600, which it is important to keep in mind that like a 4060 still costs $300 compared to the B570's MSRP of $220. So it's actually extremely impressive when it's able to just about match the performance of a 4060 for a massive price difference. Again, that's why I focused on comparisons against the 3050, which is Nvidia's price competitor in the new market, despite being an older generation. I think both AMD and Nvidia kind of use older generation products now to fill in that lower end $200 price point, because when they release new generations, they don't seem to release a new $200 product. Anyway, on the Ryzen 5 5600, notice that at native resolution, there was almost no reduction on average to the B570, although there was some. Although there's also some reduction to the other cards as well, although not a whole bunch, and it looks like the 7600, took a 2 FPS hit on average, the B570 taking like a 3 FPS hit. But when you introduce upscaling to the mix, there is a bit of a larger hit, but again, the B570 averaging 85 FPS upscaled on the 5600 and averaging 93 upscaled on the 9800X3D. So not a massive difference, and it is now slower than the 4060 when you look at the upscaled results especially. And especially on the 5600, but not massively slower than the 4060. But again, I think what's important to keep in mind is that it doesn't cost the same as a 4060. It costs the same as a 3050, where I had it 43.5% faster, although again, I was on a high-end CPU to eliminate the bottlenecking. So if you reduce its performance by, another 10% or so, if that's even, which is, I think, actually more dramatic than what was actually measured on the 5600, it's still, on average, crushing the 3050. Although it's important to note that certain games are more sensitive to this than others. For example, at Gamers Nexus, in almost every game they tested, there was almost no difference between which CPU you used, but not in every game. For example, if you look at their Baldur's Gate 3 results, they see that the B570 on a 5600 is averaging 55.7 FPS, whereas on a 9800X3D, it's at 66.7. So that's a more measurable performance difference between the CPU versions than you get in a lot of the other games. In a lot of their other games they measured, there was pretty much no difference. Like, let's see, just click on one of their other ones. Here's Final Fantasy XIV. At 1080p resolution. And here you can see that the B570s on the 12400 and the 5600 are averaging 105 and 106 FPS, and on the 9800X3D you get an additional 1 frame per second. In other words, in a lot of games, you're just not going to notice it because frame rates aren't high enough, so even if there is more CPU overhead, you're still GPU bottlenecked. So one reason why I'm bringing this up is there was a lot of comments on my videos saying that a result like this is irrelevant because I used a 9800X3D. And I think that's a little dramatic given that it seems like if you're at least on something like 5600 or 1200 from AMD or Intel, there is some noticeable drop-off in performance, although the other cards also have some drop-off in performance. It's just less dramatic. It doesn't make up for these massive performance differentials, and if from the GPUs that are actually cost the same as the B570 at around that $200 mark. So I think that is important to note. Also important to note is that the B570 was available at MSRP. I saw it stay in stock at Newegg for over 24 hours. So it was widely available. I posted this on my community page, although when I finally checked this morning, which is about 48 hours after launch, it is sold out now at this MSRP model. So, but it does look like you could have bought one for the first couple of days, and this is very normal for GPU launches. So the other big thing I saw going around was that this was a paper launch. You couldn't actually get it at MSRP. And it looks like you had at least about 48 hours or so to get one at MSRP, at least in the United States. When I looked at comments from people in other regions, though, it sounds like in Europe and other regions, availability was either non-existent or what was available was not at a great price point. So it seems like it's very regional dependent on whether the B570 was actually a pretty good deal or not. One more thing I wanted to show on this result was I did find that Tech Power Up, which has a lighter colored background, so flashbang warning again, guys. Tech Power Up, well, they didn't really focus on the 3050 and the 6600 versus the B570. They did include it in their chart, and their chart actually comes out to show an even larger performance uplift than mine. So it can depend on what games you test. They had it 56% faster than the 6600 and 69% faster than the 3050. So again, even if there's a little bit of CPU overhead, if you're on a reasonable CPU, I still do think that at that price point, it could make a lot of sense. The biggest things is you need resizable bar support in order for it to even function. Like that's a system requirement, basically. Intel just says, don't buy these without resizable bar support. But also if you're on older CPU platforms. So I do think that kind of 5600 and 12400 are kind of where, okay, you might see a little bit of CPU overhead issues in certain games. In a lot of other games, you're not going to see it. And overall, it's probably still going to be a lot faster than something like a 6600 or a 3050, just due to you're usually GPU bottlenecked, and this GPU is going to perform a lot better in most situations. In general, Arc is a lot more hit or miss, and there's some outlier games where they don't perform well. And I'd kind of throw that into where you'd probably see that. But again, on older systems than that, that's where I'd probably question whether it would make sense to go with this, because you might be more likely to see the CPU overhead. And circling back around to saying, so that's why I think something like a Ryzen 5 7400F, if we got these worldwide available at around $100, that might start to be interesting to pair with something like a B570, where you get a pretty good gaming CPU with it at a pretty low cost overall, especially on like the the 620 series motherboards and things like that. I'm just curious what sort of a brand new build you could do on a fairly modern platform at a pretty reasonable price point, because that's been something that I just feel like has been lacking in the more recent CPU and GPU launches, is really good budget offerings down in that like $100 CPUs and $200 GPUs. A little bit more news on that regarding availability of the Battlemage GPUs is the B580s. These ones seem to be much more dramatically like an instant sellout, or didn't seem to be stocked in the US as well, and that was a bit of an issue at MSRP. Video cards spotted an ONIX branded version of the cooler for the B580 showing up on Newegg, although not yet in stock. But that does indicate it's probably going to come in stock, and this one's not much above MSRP on the B580. Again, we're talking B580 now, not 570, so MSRP 250. And they do have a model from ONIX that is only $10 above the MSRP, so not bad there. Another one that's $20 above the MSRP. Again, the closer you get to $300, though, you're directly head-to-head against that 4060. And while it has the VRAM difference, you know, there are still some quirks with Intel GPUs. So I think the closer it is to its actual like 250 MSRP, the more interesting it gets. So these never really seem to come in stock yet. They're just now being listed. So I'd maybe keep my eye out if you are looking for a B580 for maybe that $260 model coming in stock at Newegg potentially soon-ish. Anyway, a couple more quick things to note. I've reported on Final Fantasy VII Rebirth coming soon on PC, as well as its PC system requirements. And there's now a system requirements video, not just, well, requirements video, but actually a graphics preset performance test video directly from the Final Fantasy YouTube channel, where they show the minimum recommended and ultra configurations. So in this video, you see a 30 FPS gameplay at 1080p low settings with a Core i3-8100 and an RTX 2060. And they do, show what that looks like, and it looks pretty good. Like, the low graphic settings don't seem to be a disaster or not. I'm curious if there's any built-in upscaling. They then move up to their recommended GPU-CPU combo of a Ryzen 7 3700X and RTX 2070 at a medium graphics quality, showing 60 FPS. The specs on all of that is, not too far behind something like a PS5, so that kind of makes sense why they might be using those types of specs for the recommended mode. And again, showing it playing at 60 FPS, and then they move on to their ultra settings, which is graphics quality high at 4K resolution on an i7-10700 and an RTX 4080, showing 60 FPS. One thing they don't mention is upscaling, but that doesn't mean they aren't using it. And I know with the first Final Fantasy VII Remake game on PC, it defaulted to using dynamic resolution scaling. So I'm curious if that's happening in this. They're not really specifying for sure. So Anyway, there's that. The main interesting thing on the system requirements for Final Fantasy VII, if you didn't watch my video on it, is that it does seem to require RX 6000 series and up or RTX GPUs and up. Most likely not due to ray tracing, because as far as I can tell, the game doesn't have ray tracing. It's more likely due to mesh shader support. Anyway, in the system requirements world, I'll also mention that the first Berserker Khazan has a demo out now for PC and has PC requirements revealed. So if you are interested in this game, the PC requirements don't look crazy, and there is a demo out where you could try it out. Looking like the minimums being an i3 6300 or Ryzen 3 1200, a GTX 970 or RX 580 or Arc A580. And looking like the recommended is a Core i7 6700K, Ryzen 5 3600, 16 gigabytes of RAM, RTX 2070 or RX 5700 XT, or Arc A750. That's for 1080p 60 FPS with high graphics settings. So this is not looking like it's going to be incredibly demanding unless they're, you know, like saying 1080p but actually using like performance mode upscaling to get there or something like that. This is a UE4 game, not UE5. So that's something to think about. All right, that's what I've got for you guys today. Hopefully you found the video useful and or interesting. I hope all of you have an excellent day.